We're with Alexandria Technical Community College, part of the Mechatronics program. My name is Schonberg.
I'm Klover.
And this is the Mechatronics arm wrestling machine, otherwise known as the M.A.W.M 9000.
Klover, I'm the pneumatics kind of guy for the M.A.W.M 9000. Here is our pneumatic schematic. On the schematic, you will see our electric regulator that controls dynamic pressure. In here, this dash box is the manifold, and these are our DCVs, or directional control valves, that control the flow and pathways. And then out from there, you'll see the meter out flow controls that regulate the flow back and forth, so it's not too jagged, to our secondary and primary cylinders you see here and here. Following the schematic in the real world, you see the source pressure line here going to the electric regulator. And then the regulated pressure goes to the valve manifold here, which you can see then the work ports come all the way down through here to our cylinders, where you can see the flow controls here. And it goes to our secondary cylinder back here.
Hello, I am Hulke, and I was the electrical kind of guy. And here is the wiring diagram that I designed. So here we have our power supply, which is 24 volts, our distribution blocks, our fuses. Here's our input side. So we have 4 cylinder position sensors and 3 push buttons, an e-stop, a green push button, and a red push button. Here we have 2 potentiometers in line, or wired in line. The first one controls the second one's maximum output signal, which is 10 volts. And then on the output side, we have our analog regulator, electric regulator, that runs off of that 0 to 10 volt signal from the potentiometers. We also have a smart LED over here that's a 3 color changing banner LED, and then our 4 solenoids for the cylinders. Alrighty, so now we're going to look at the electrical panel layout that I designed here. So as you can see, we got the valves on the top, e-stop on the top, all of our panduit for the wiring, the enclosure on the right, the power supply below it, and the distribution blocks, the PLC regulator. So if you'll take a look down here, on the top we got the valves, the e-stop, the enclosure, power supply, fuses, distribution blocks, the analog electric regulator, the PLC, all our panduit.
Hi, I'm Schonberg. I was the mechanical engineer for the M.A.W.M 9000. Here you can see a printed view of our 3D model. The software we used was SolidWorks. Here we have one of the more interesting mechanical joints. This allowed us to have 2 axes of movement in one area to simulate an elbow to create a more realistic experience while arm wrestling. As you can see here, we have the electrical and pneumatic panel, which is laid out as specified by the engineers. The implementation of that unique joint was welding on 2 plates to a shaft that runs through 2 bearing blocks, and that plate here holds on to another arm. Now if you look, that allows us to have both axes of movement in that one area. This armature here is attached via a cable and pulley system to these unique fixtures that we designed and precision machined. Precision came in that we had to make it big enough for this cable to go through, hold the ball inside, and thread onto the end of the cylinder rod to hold it in place. I also did the controls engineering. So here we have a printout of the logic. It was written in ladder diagram in the software Connected Components workbench. We used an Allen Bradley 820 PLC, which is this device here. This was to accommodate our analog input, our potentiometer, and our analog output, our electric regulator. This is also required to accommodate the amount of digital inputs we had. One thing that's neat is we have 4 base difficulties: easy, medium, difficult, and extreme. These different difficulties set the base PSI that we allow through the system, which increases the force output of our cylinders. Also, as we're progressing our cylinder towards the wind state, we have reed sensors that detect position, and so as you progress it, it increases the PSI during the one match. One thing we had to keep in mind while designing this system was safety. When arm wrestling, if you're getting in a pickle, you don't want to keep going. We designed this e-stop to kill any forces on your arm very quickly. This allows a safe mode in case you need it. We'll demonstrate an arm wrestling cycle. It begins with enabling the system with the green push button, selecting your difficulty with the potentiometer. We're going to use the medium difficulty for this demonstration. You will then get into the position and wrestle. When you get to the win position, our cylinders extend to relieve any force on the armature, and you can hit the reset button to have it become ready for the next person to use it. Thanks for watching.